Welcome to the Chapter 2 video. We're only doing 2 sections of Chapter 2 because I want to really focus on proofwriting. And so Chapter 2 is going to be, for us, the introduction to proofwriting, and we will be doing proofwriting more throughout other chapters. So for our purposes, Chapter 2, we're looking at reasoning in algebra and geometry, and our first objective is to connect reasoning in algebra and geometry. So what is proofwriting? A proof is a convincing argument that uses deductive reasoning. Essentially, a proof is using only logic and reasoning in order to come to a conclusion. So we'll see several examples. There are 2 different types of proofs, and in this class, we're only looking at the first one. So the first type of proof is a 2-column proof, where you have 1 column of your steps and 1 column of your reasons. The other type of proof, which we won't be looking at in this class, is called a paragraph proof. And when you're writing a proof, the line to get to the end of a proof is not always obvious. It's kind of like a maze where you have to work your way around through the maze in order to find the correct path. So as we get started, usually what will happen is I will give you one side of the proof and you will be filling in the other side. That way it's a little bit easier to see the steps, but we will get to the point where you are able to fill in both columns of the 2-column proof. So how do we know what goes in those columns? Well, we have some properties of equality, and these are, for algebraic proofs, going to be the reasons that you give as you go throughout the proof. So what are these properties? These are properties that you should be familiar with from algebra. So our first property, if A equals B, then A plus C equals B plus C. What happened here? We added C to both sides of the equation. So this is called the addition property of equality. And we're going to abbreviate property of equality as POE. So property of equality will just be POE. So this is the addition POE. And then our second property here, if A equals B, then A minus C equals B minus C. What happened is I subtracted C on both sides of the equation. This is the subtraction POE. So notice the property of equality is really just naming what is the algebraic equivalence that we used. So in this third one, we multiplied both sides by C. This is the multiplication, POE. This one is division, so this is the division, POE. And then we have a property where it says if A equals B, then A can be substituted for B. So this is when we have an equation and we have a value given and we use that value to substitute into the equation, for example. And that is the substitution property. And for the substitution property, you can just write substitution. You don't have to write the word property. We have this next one, says if A equals B and B equals C, then because A equals B and B equals C, we can say that A must also equal C. Now we can call this substitution, but more specifically, this is the transitive property of equality. Transitive, whoops, I forgot the N. Transitive property of equality. And then we have our next one, A times the quantity of B plus C equals A times B plus A times C. So this is the distributive property. So those are our properties of equality. They should be familiar for how to solve equations in algebra. Our next property is the symmetric property of equality. Now these last 2 get confused sometimes, so I want you to pay special attention to some of the differences. Symmetric means that there's something the same about it, Okay, so for the symmetric property, we say if A equals B, then B equals A, right? A equals B, then B equals A. There's this symmetry about it. We can also say if A is congruent to B, then B is congruent to A. So we can replace that equal sign with a congruence sign for this property. Our last property, the reflexive property, says A equals A. Okay, so reflective, like a reflection in a mirror, shows you the same thing back. Whereas symmetric, they can be equal to each other and you can write it in either way. Okay, so reflective is the one where you have something equal to itself, like the mirror shows you yourself. Let's look at using these in a proof. So if we are given that 2 times the quantity of x minus 4 equals 5x plus 10, we want to use only these properties in order to prove that x equals negative 6. So the steps for solving that problem, which you should be able to do, are written down in the statement column. The thing that makes this a proof is that now we're going to write a reason for each step. So the reason should answer, how do I know that this is true? So in our first step, how do I know that this is true? Well, that's what was given to me. So our reason here is given. For our next step, how do we know that this is true? Well, what changed between step 1 and step 2 is that the 2 was distributed. So the reason for step 2 is the distributive property. In step 3, how do we know that step 3 is true? What happened from step 2 to step 3? Notice our 2x became a negative 3x. How did it do that? Well, we subtracted 5x from both sides. So this is the subtraction property of equality. On step 4, what has changed? Well, the 8 was added to both sides of the equation. So this is the addition property of equality. And then lastly, what changed from step 4 to step 5? We divided by 3 on both sides. So this is the division property of equality. And now our statement matches exactly what we wanted to prove. It looks exactly the same. It has to be in the same order. It has to say exactly the same values. X equals negative 6, x equals negative 6, so we're done. Let's take a look at another one. All right, in this example, we're just looking at one step, so one step at a time. What is the property that takes us from the first step to the second step? Okay, so when we're looking at this, what has changed? We've gone from 2x plus 9 to 2x, so that means we've subtracted 9 from both sides. This is the subtraction property of equality. In part B, we went from angle O is congruent to angle W, and angle W is congruent to angle L. And then we said, okay, so then angle O is congruent to angle L. What property lets us do that? The middle's matched, and therefore this is the transitive property of equality. If you say substitution, I will accept that for this one. But more accurately, more correctly, this is the transitive property. And then C, we have the measure of angle E equals the measure of angle T. So then how do we know that the measure of angle T equals the measure of angle E? This is one where we had a statement and we just switched the sides. And so that is called the symmetric property of equality. Okay, so we've done a few where I've given you the steps and we've just given the reasons. Now let's see if we can write the steps and the reasons. Okay, so this one, we're going to look at a geometric proof. So what are we given? We're given that angle AOM and angle MOC are supplementary. So what does supplementary mean? Supplementary means they add up to 180 degrees. So here we have a diagram, it shows us our angles, and we want to prove that x equals 50. So we're going to start out our first statement, and the first statement should be what information you were given. So we are given that angle AOM and angle MOC are supplementary. And the reason is because that's the information we were given. So then our second step can be to use that information. What do we know if those two angles are supplementary? Well, if they're supplementary, we know they have to add up to 180 degrees. So we can say now that angle AOM, which is 2x plus 30, plus angle MOC, which is x, equals 180 degrees. How do we know that? That is the definition of supplementary. So then what can we do from there? Well, our third step, if I was solving this, my next step would be to collect like terms. So here we have 2x plus x is 3x plus 30 equals 180. That is collect like terms. And then our next step, what would we do next? We would subtract 30 from each side. So now we have 3x equals, we're not going to draw the subtraction in our proof, but if you wanted on a separate piece of paper to work out this problem separately so that you can see the algebraic steps the way that we've done them before, that's okay, but you're not going to include it in your proof. So you might want a separate scratch paper for that. So minus 30 gives us 150. And what did we do? We subtracted, so that's subtraction, POE. Next, we would divide by 3. So again, we're not going to draw the division in our proof, but you can have scratch paper for that if you'd like. Divide by 3 is x, divide by 3 is 50, and 5 is the division property of equality. Now our statement matches exactly what was given, so we are done with the proof. Let's do another. Now there's not always one way to solve a proof. Sometimes there are multiple ways that you can take. This is an example where there are a couple different routes you can take, but you'll always end up at the same place. So, example 2, given that ray AB bisects angle RAN, we want to prove that x equals 75. Again, we're going to start with the information we know. So our first step is just what we know, which is what was given. AB bisects angle RAN. And we know that because it was given. Step 2, okay, so what information does that tell us? Well, if a ray bisects an angle, it creates two congruent angles. So that means angle RAB is congruent to angle BAN. How do we know that? Because that's the definition of angle bisector. Okay, step 3, what does the congruence tell us? That means that those angle measurements are equal. So we know that x degrees is equal to 2x minus 75 degrees, because that's the definition of congruent. So now we've gotten to a point where we can start using our algebraic reasoning. So if I have x equals 2x minus 75, what do I need to do? I need to isolate x. So I can subtract 2x from both sides. So minus 2x, we get negative x equals negative 75. And that's by our subtraction property of equality. And then finally, we wanted positive x, we have negative x, so we need to divide by negative 1. X equals 75 by the division property of equality. So the reasons are really just going to be the steps of how do I know what to do next? What is the next step that I'm taking? Okay, let's look at the next page. So we're continuing learning about how to write proofs, but now we're going to include proofs about theorems and about angles. So those special angles that we just learned about, in our last couple lessons, we're now going to learn how to prove that those are true. Okay, so remember, the definition of vertical angles are the angles that are created by opposite rays. So the two angles that are opposite of each other from two intersecting lines. It looks like an X, right? It's the angles that form from an X. So the vertical angles here are congruent, and they are angles 3 and 4. So angle 3 and 4 are congruent, which means that their measurements are equal. So what we'd like to do is prove that this is true so that we can use it in other proofs, right? We've used it, we've seen it, now we need to prove it. And in order to prove it, we need to go back to knowing things that we knew only before we knew that vertical angles were congruent. So for this proof, since we're proving that vertical angles are congruent, we cannot use the property that they're congruent because that would kind of defeat the proof. Okay, it'd be like me saying, oh, well, blue is the color of that wall because if I look at the wall, it's blue, right? You can't use something to prove itself. So we're only going to use the given and the information that we knew before we learned about vertical angles. So we're going to start with given angle 1 and 3 are vertical angles. So we're identifying them as vertical angles, and what we want to do is prove that they're congruent. So step 1, angle 1 and angle 3 are vertical angles. That's what was given to us. So this is us defining what a vertical angle is. And then we say, okay, well, if angle 1 and angle 3 are vertical, we would like to prove that they're congruent. And what do they have in common? Well, they're both supplementary to angle 2, right? They both create a linear pair with angle 2. And so since 1 and 2 are supplementary and 2 and 3 are supplementary, we can say this is because linear pairs are supplementary. So if we want to compare angle 1 and angle 3's measurements, then we need to find something that they have in common so that we can compare them. And so we said they're both linear pairs. That means they're both supplementary. And that means that their sums equal 180. So we can say angle 1 plus angle 2 is 180. Angle 2 plus angle 3 is also 180. This is from the definition of supplementary. And if both of them have the same sum of 180, notice they're equal to the same thing, then we can set them equal to each other by the transitive property of equality. If they're both equal to the same thing, then they must be equal. And then from here, we go from measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3 to just measure of angle 1 equals measure of angle 3. Well, how did we do that? We subtracted the measure of angle 2. So this is the subtraction property of equality. And remember, we said that works. All of those properties of equality also work as properties of congruence. And so I would write this as a separate 6th step, but in your book, it puts it as the same step together. So that's how I listed it here. If they're equal, then they must be congruent. Slash congruence. Now our statement, 1 is congruent to 3, matches exactly what we wanted to prove. So that's how we know we're done, when our statement matches exactly what we wanted to prove. So now we know that vertical angles were congruent. And now we can use that in our future proofs. Let's do another example. Proofwriting, it doesn't get easier until you start doing it. You've just got to do some proofs, and then it will kind of get easier to see what are the steps, what are the questions that I have to ask myself as I'm writing a proof. So we did one where I gave you the statements and then we made the reasons. Now we're going to make one together where we're going to create the statements and the reasons. So the first thing we are going to do is write our table, our 2-column proof table. Statements, reasons. So we are given that angle 1 is congruent to angle 4. What we'd like to prove is that angle 2 is congruent to angle 3. So we start with what's given. Step 1, angle 1 is congruent to angle 4. How do we know that? It is given. Step 2, well, we just proved that vertical angles are congruent, so what we can say now is that angle 1 is congruent to angle 3, and angle 4 is congruent to angle 2. So how did I know to use that? Well, I'm working with angles 1 and 4. I'd like to be working with angles 2 and 3. And what are their relationships? Well, 1 and 3, 4 and 2 are vertical of each other. So I can say angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4, and that is by vertical angles are congruent. We just proved that above. So then what is our next step? Well, like I was saying, we have a statement in terms of angle 1 and 4. We'd like it to be in terms of angle 2 and 3. And so we can now substitute our congruences. Instead of angle 1, I'm going to write angle 3. Instead of angle 4, we write angle 2. And that is the definition of substitution. Substitution property. And remember, you don't have to write the word property for substitution or distribution. Step 4. So now I have angle 3 is congruent to angle 2, but what we want is that angle 2 is congruent to angle 3. So we need to switch their order. Angle 2 is congruent to angle 3. And what property allows us to do that? That is the symmetric property of equality. And now our final statement matches exactly what we wanted to prove, so we know that we have done it. Okay, let's take a look at our last page. On this one, we're first going to just write out the steps so that you can see you already know how to solve these, and then we're going to put them into a proof. Okay, so first, I'm going to just write out the steps. If I want to solve for x, these are vertical angles. We just proved that vertical angles are congruent, so I can say 3x equals 2x plus 40. And then to solve for x, I need to subtract 2x. So x equals 40. Now, if this was a proof, those are the exact same steps I would use, but I need to give a reason as well. So I'm going to say reason, and this time I'm going to say steps because I have some scratch work in there. And so the reason, the first one we said was because vertical angles are congruent. And then the second step, what did we do? We did subtraction. So this is subtraction, property of equality. So if you wanted to, you could go back and you can look at all of the work we've done over the past few days. And if you can write a reason for every step that you've done, that is proof writing. So you've already been doing the statement column of proofs every time you show your work. On our next one, we want to solve for x and y. So it doesn't really matter which one we solve for first. Let's do x, just because of alphabetical order. That's the only reason. So if these two angles are vertical, then they must be congruent. So 2x equals 76, divide by 2, x equals 38. And then we want to solve for y. Well, y, we could set it equal to 2x, or set it up with 2x, or we could set it up with 76. These two angles are a linear pair, so they're supplementary. Y plus 76 equals 180, minus 76, y equals 104. And then again, I'm going to set this up, steps and reasons. How did we get this first step? Well, vertical angles are congruent. What is the next step we did? We did division. So this would be division, property of equality. And then our next step, we said y plus 76, where did we get that from? That's from linear pairs are supplementary. And then finally, y equals 104 was from the subtraction property of equality. Okay, so again, this just demonstrates you would have been able to do all of these steps. If you can name their reasons, then you can write their proofs. And if you can do the steps, then you already know the reasons. Sometimes the hardest part is coming up with what's the name of the reason. Okay, now all of the information that we learned, you can use in a proof unless it's what you're proving. So you can't use what you're trying to prove in the proof that you're writing. So let's take a look at our last example here. Example 3, we are given that angle 1 is congruent to angle 3. I'm going to go ahead and mark it on my diagram here. And what we want to show is that angle 6 is congruent to angle 4. Okay, this is very similar to one that we did before. So what's the relationship between the angles that we know and the angles that we want to know? They're vertical, right? Angle 1 is vertical with angle 4. Angle 3 is vertical with angle 6. And so that tells me I'm going to be using vertical angles in my proof. So we're going to write statement, reason, make our 2 columns. Always start with what you're given. So the first statement is going to be angle 1 is congruent to angle 3 because it was given to us. Okay, our next step, remember we said we have angle 1 and 3, we want angles 4 and 6, so we're going to write that those give us vertical pairs. So we have angle 1 is congruent to angle 4, angle 3 is congruent to angle 6. And how do we know that? Because vertical angles are congruent. Our next step, we want to substitute. We want this equation, but with our new angles. So we say angle 4 is congruent to angle 6 by substitution. But that doesn't match our proof. So we want it to be 6 and then 4, so we need to switch them. Angle 6 is congruent to angle 4. And how do we do that? That is by symmetric property of equality. Now they match exactly, so we are done. Okay. I do want you to think about this proofwriting process over the weekend so that when we come back on Monday, we'll be able to practice it together.